Here we see a lava rock from La Palma from the 2021 eruption under the microscope. This is at a magnification of 4, and here we see larger crystals and tiny needles of plagioclase. Here I can turn the stage on the microscope and then the colors change. So there is a larger crystal coming into the field of view, and you can see it's got some internal textures. And when we pass polarized light through these crystals, then the different colors that emerge here, they tell us about the exact composition and the type of these crystals. So there's also small white needles, these are plagioclase. Then there's olivine and pyroxene, and many of those crystals have zones like this one here. There we have growth rings, and this is a broken crystal on the upper part, but the lower part still preserves the growth zones. So we can work out the details of the growth history, and that helps us, of course, to understand how magma is stored under the volcano, because the crystals have come with the magma, and therefore they have experienced this journey. The variety of crystals is also very useful. So here we have another one. This is zoned. You see the zoning on the left-hand side and the larger inclusion on the right. And here is some bubble, some vesicle holes. So these are, of course, in the sample, and they will be, well, transparent if there is plain light coming through. Here's an olivine crystal, and it's got a nice light blue interference color, and it's partly reacted. This is in the process of being eaten up. It's been resorbed by the magma, and you can see that it's what I would call an unhappy crystal. So then this, of course, implies that there's many generations of crystals in there. And here we have a zoned crystal that's been partly eaten up. You can see the greenish, dark greenish, outer zones and the interior. And we can have a little look at this when we zoom in. So here we can now see the upper part that is resorbed, so the magma is eaten in, while some of the other portions of the crystal are still intact, and they have a shape that is euhedral. So this crystal likely is not in equilibrium with the magma. It's not of a corresponding chemistry, and therefore the magma will be aggressive with it. It will start to dissolve the crystal. Here we have another beautiful zoning in a pyroxene crystal, and these different zones are, of course, a reflection of the various growth stages of this particular crystal. So here's a crystal clot, and you see that there are several crystals that have grown together. And let's go a little bit further. There's another olivine, and here we have a stunning zoned pyroxene. Here's another partly resorbed crystal, and here's a crystal fragment. And here we have an olivine that comes with a pink interference color now, and there's a bit of variation along some fractures. The reality is that olivine has no cleavage, so it doesn't break in a systematic way. It breaks irregular, and therefore we have irregular cracks here going through this crystal. This is a good indication of the crystal type as well. So here we have an aggregate, a glomerocryst, or a crystal clot, and this means this is recycled from some crystal mush, maybe accumulate at the base of a magma reservoir or from the sidewalls of a magma reservoir. And there we see a larger crystal that has grown together with a series of smaller crystals.